Hello, everyone. Welcome to the course Principles and Applications of Mechatronic Systems. I'm your instructor, Xiang Jiwen. Today, we will begin Chapter 3, focusing on position detection sensors in mechatronic equipment. In modern mechatronic systems, position detection sensors play a crucial role. They provide precise information about the position of system components and ensure the stable and reliable operation of equipment. In this lesson, we will learn about Hall position sensors, photoelectric position sensors, and eddy current position sensors. Let us begin with the Hall position sensor. In 1879, scientist Edwin Hall discovered the Hall effect. When a thin semiconductor plate carrying current is placed in a magnetic field B perpendicular to its surface, a voltage appears across the sides of the plate, as shown in the diagram. This is the Hall voltage. The principle behind this is that the charge carriers in the semiconductor are deflected to the sides by the Lorentz force, resulting in accumulation and the formation of a Hall electric field. This Hall field generates an electric force opposite to the Lorentz force, which prevents further accumulation of carriers. When the electric force and the Lorentz force reach equilibrium, a stable Hall voltage is established across the two sides of the plate. The Hall position sensor is widely used in practical applications. In proximity switches, components such as magnetic steel, magnetic conductors, and moving vanes work together to detect whether an object is approaching, based on the Hall effect. In travel limit control, Hall sensors can be applied in robotic arms or CNC machine tool platforms to ensure that moving parts operate within designated limits, thus avoiding collisions and equipment damage. Next, let's look at the photoelectric position sensor. In industrial applications, it is commonly found in through beam, shaded, reflective, and radiative forms. Its working principle mainly involves using the switching action of a transistor to generate photoelectric pulse signals, thereby realizing position detection. These four operating modes are illustrated as shown in the diagram. Due to their low cost, compact size, and reliable performance, photoelectric position sensors are widely used in automatic control systems, production lines, security alarms, and household appliances. On production lines, they can detect product height differences, eliminate missing parts, and determine workpiece positions. In security and anti-theft systems, the interruption of light by an object can trigger the sensor to issue an alarm. In strip centering control, the sensor ensures that the strip remains in the correct position during transport. Finally, we will study the eddy current position sensor. This sensor uses a detection coil as the sensitive element. When a metal object approaches the coil, it generates eddy currents that absorb the oscillation energy, thereby weakening or stopping the oscillation. The detection circuit converts the oscillation or stop states into switch signals for output. In practical applications, eddy current sensors are often used for displacement measurement, providing high-precision measurement of object displacement. In vibration monitoring, they enable real-time detection of equipment vibration to ensure safe operation. In the field of thickness measurement, the sensor probe detects the thickness of metal plates by sensing their proximity. Now let's summarize. The three types of position detection sensors we studied today each have their own characteristics and applications. The Hall position sensor, based on the Hall effect, performs excellently in proximity switches and stroke control systems. The photoelectric position sensor, with its multiple working modes and wide range of applications, plays an important role in both industrial and domestic environments. The eddy current position sensor, with its unique working principle, excels in displacement, vibration, and thickness measurements. I hope you will review today's material carefully after class and think about more real-life and industrial application scenarios of these sensors to deepen your understanding. That concludes this lesson. Thank you for listening. See you next time.